Hi guys, welcome back to my channel and this is my fifth lecture on machine learning. In previous video, we built our first machine learning model using a real world example where we predict the salary based on the year of experience and where we train the model and generate the prediction. Where we train the model and generate the prediction. But today, an important question is arrived. But today, an important question is arrived. How do we know our machine learning model is actually good? And how do we know the model is learning properly or not just remembering the data? Yes, to answer this question, we need to understand the very important concept in machine learning, that's an training and testing data. Yes, and do not worry, you are completely beginner. We do not go in advanced mathematical or and no confusion. You are completely beginner. This video is for you. Yes, and this video is for you. Yes, then start our today's problem statement. Let understand the problem first. In the last video, we train the model. We train our model using all available data. Using all available data. But if we train the model and test on the same data, then how do we know the result is correct? Yes, the model may give the correct prediction. But that does not mean this will be work in a real life. Yes, this create a big problem. Yes, this create a big problem. We cannot tell whether the model is learning or just memorizing the data. Yes, yes. For example, we can take a real life example. That's a face recognizing. In a face recognizing, we use a training data, a large data set of face, each with identifying the features and associated with the labels or names. And, and next, we use a testing data. Testing data means a new image or video frame to see if the model can correctly match or verify the face it not seen before. Yes, it's not seen the before. Yes, I think you understand that. We go further, we go further. Then to solve that problem, we split the data set into the two parts. Yes, first one is training data and second one is testing data. And training data is used for training models to 70 to 80%. Or testing data is used to 20 or 30%. Yes, and training data is used to teach the model. Yes, and testing data is used to evaluate the model. Evaluate the model. This separation helps to check the model performance and unseen data just like a real world scenario. Yes, then what is mean by a training data? Let's see. The training data is used to train the model. The training data used to train the model. The model sees the input, the model also sees the output. Yes, this is the learning phase where the model understands the relationship between input and output. Yes, and usually the training data use 70 to 80%, 70 to 80% data to training purpose. Yes, I think this also you understand what is the training data. We go further, and we can see the what is the testing data. Yes, testing data is used to check the performance of the model. The model has never seen the data before. Yes, this helps to understand how accurate model it is. Yes, how will it will perform in a real world you can say situation. Usually around 10 to 80% of data is used for a testing purpose. Yes, for testing purpose. That's it. That's it for training and testing data before we further go with practical implementation. Yes, and last, why we split the data set? Then why we split the data set? Yes, we split the data set to make sure the model learn, not memorize. Yes, model work well on a new data. Reliable output. Yes, a good machine learning model performs well on the both training and testing data. Yes, what? Listen carefully. The good machine learning model perform well on the training and testing data. Yes, I think you understand that all this thing we go in a practical implementation. This is the most important thing to understand before we can go further in a practical implementation. I think you understand that. I think that what is a testing and what is a training and testing and why we use the training and testing data. Training and testing. Yes. Then let's go with a further practical implementation of testing, training and testing data. Okay. Hey, now we can see the practical implementation of training and testing. Yes. In this code, we can build a very simple machine learning model that predicts the salary based on the year of experience. Yes. Using a linear regression. It's the same example and it's the same code as a previous video. But we can use here a splitting. Yes. First of all, in this code, first of all, we can import the library. We can import the library. The first library is used to handle the data, and second library is used to create our machine learning model, and third library is the most important for today's video. This and that helps to divide the training and testing part. Yes. And fourth level we can discuss in a further in a further first of all we can run that cell and in a next cell we can load our data set from an Excel file and we can convert that into the data frame. Yes, and a data frame is like a table with row and column. We can see here. Yes, we are seeing here in row and column. And in the next, we can run this slide, we can run this cell. Yes. And next, we can split the input and output. Yes, we can split the input and output. And input and output and X is an experience and Y is a salary. Yes. And also we can see what inside the X. Yes, we can see here. Yes, X contain the input feature like year of experience. Yes, and also we can see Y is inside the Y contains the output of salary. This is the output. That means salary. Yes, and in a further code, this is a very important part for training and to split the training and testing data. Yes, yes. In this part, we split the data set into a training and testing data. Yes, 80% of data we use for a training and 20% data we use for a testing purpose. Yes, we can see here what we can do here. Yeah, we can take a train test split using we can use here in an import statement. In that we use x and y. Yes, x is an our input and y is an our output value. Yes, we can give to here, and we can use 20% of testing data. We can see here. We can assign our testing size is 0.2. That means our testing data is 20%. Yes, let's we can run that cell. Yes, in a further cell we can see we can, in a further cell we can see. and we can see or we can confirm that the training and testing data size match correctly. Yes, the training, you can see the training, we can see the training data length. Yes, it's in a 16. 16 means our actual data, our actual experience is from 1 to 20. Yes, and we can use for a training purpose 16 data from our data set. And further say we can see for a testing data. And for testing data, we are using a 4 data set from data set. Yes, that means our 80-20% ratio means 80% data is used for a training and 20% data used for a testing data. Yes, I think I think you guys understand that. Well, how to split the data. Yes, in a further cell we can in a further cell we can create the model. Here we can create the linear regression model. The linear regression find a straight line relationship between input and output. We can discuss in a last video. Yes, what is a linear regression? In a further cell, now we train the model using we can train the model using the training data set. In a further cell, here we predict the salary. Here we predict the salary of 20. We can do here some additional work. We can predict the salary of 21 year guys. What we can predict? See what our model predict. Our model predict 42,662. Six 662 rupees. Yes, it's our it's I think it's our correct output. I think it's our correct output. Let's see our actual code. What is the salary of 21 year guys? Yes, we can see here 42,000. Yes, 42,000. And now our model is predict for 21 year guys is 42,000 662 rupees. Yes, I think that's probably a good prediction. Good prediction. Then how to check our model accuracy? Then how to know our model accuracy? How model predicts this accurately? Yes, accuracy. To find the accuracy, we are using a R2 score. Yes, we are not in this video. I not explaining the what is a R2 score. The R2 score is usually used for seeing the accuracy of model. In in our model, we get a 98% R2 score. For today, I think I think you are understood that what we are doing in this code. And and so we today we learn why training and testing data are most important in machine learning. Training data is used for learning and testing data is used for evaluating model. And splitting the data set helps us building a machine learning model that actually works in a real world application. Yes, in the next video we will learn about what is a overfitting and what is an underfitting. Why some model perform well on a training data but fails in a testing data. If you are learning a machine learning from scratch, subscribe the channel and like the channel for more beginner friendly machine learning videos. And thank you guys. See you soon in the next video.